The
Okay,
broadcast is now starting. All attendees are in listen-only mode.
Good morning, ladies and gentlemen. Welcome to the PASS Virtualization Virtual Chapter meeting for the month of March. We're honored today to have Bob Ward from Microsoft talking about Linux and Docker today. So hold on to your seats because I know he has a lot to talk about, and it's very good. This will be recorded, and we'll send out the link and any notes and PowerPoint slides after the presentation. Bob, take it away.
Tom, thank you very much. Can you hear me okay?
I hear you just fine.
Perfect. Hey, I'm honored that the virtualization chapter would invite me today to talk about SQL Server on Linux and Docker, and thank you for all of those here who are attending live wherever you may be across the world to hear about SQL Server on Linux and Docker. I am Bob Ward. I'm a principal architect at Microsoft with the SQL engineering team. This is my 25th year at Microsoft, working on all versions of SQL Server, going back all the way to SQL Server OS2 1.1. SQL Server on Linux is actually an irony for me at Microsoft. I actually was a Unix developer doing C++ and Oracle work before I joined Microsoft in 1993. So I never thought I would see the day that we would embrace Linux as an ecosystem and as a platform to run SQL Server. So I'm pretty excited to get an opportunity to talk to you about it today. The deck I'm about to go through is one I've just recently presented at a major conference called SQL Bits in Europe. And it's kind of built for longer than an hour time frame. So we're not going to go through every single slide we have out there. But if you look at the slide you have in front of you here, the actual deck that you're seeing, that you'll see on the recording, is available for you to go through yourself at aka.ms/BobWardMS. Look for the SQL Linux folder, and you'll find this actual deck that I'm presenting. And then I love for people to see the demos I'm doing. There are 3 demos throughout the deck. I'll only do a couple of them. But I have a GitHub repository now. If you just look for Bob SQL GitHub, you will find a repository of demonstrations and things that I've done for SQL Server and SQL Server on Linux. And so the demos I'm showing you are all available for you to download from my GitHub repo. And I love talking to people about this topic. So bobward@microsoft.com is my contact information. If you go through this information today and there's something that just didn't quite strike you as you understand, or you have further questions about deploying SQL Server on Linux, I really don't mind you contacting me directly at my email, and we can have a chat later about your questions. So let's get into this topic. This topic is specifically about SQL Server and Linux and Docker containers, but as you know, SQL Server 2017 is the basis and the foundation where we released this functionality. So this talk is not going to be focused on SQL 17, but I will talk about some of the features a little bit here in a couple of slides that we've done as a differentiation for this release. And the biggest thing you see on your left is the fact that we're doing SQL Server on new platforms now other than Windows Server. But we continue to be an interesting leader in performance, in security, and new functionality outside the normal scope of a database engine like R and Python and machine learning and graph data types. And then BI is still a big story for us, especially with our ability to do now end-to-end mobile BI capabilities. And if you had to look at SQL Server 2017 at a larger scale, and what's different about it between even, say, SQL Server 2016, which is the foundation for SQL 17. You know, look at this picture here. If you even start from the top left-hand corner and kind of go to the right and then circle back to the left at the bottom, you can see we now have platform of choice for you. We have features like adaptive query processing and automatic tuning for intelligent performance within the database engine. We have clusterless availability groups. I'll touch a little bit on that later in the presentation. We now have graph data types built into the T-SQL language. And then now taking things like machine learning and baking them and co-locating them with the SQL Server engine for R and Python and things like native scoring. So if you're looking for the overall SQL 17 pitch, you know, this is the functionality that's different between it and previous versions. And if you go to that website, aka.ms/BobWardMS, I've also got a deck out there for SQL 17. You can get a better view of all the functionality in it. But we're here to talk about SQL Server on Linux. And out of the gate, one of the first questions is folks, especially that don't understand Linux, is what Linux versions do you support for SQL Server? And if you looked at the left-hand side, we made a very conscious decision to support Red Hat, SUSE, and Ubuntu as the official distributions that are supported for SQL Server on Linux. There's hundreds of distributions out there, but we picked those because they're very popular, and we have strong partnerships we've built with the organizations behind these distributions. For example, on our support organization, we have a very tight partnership with these other companies so that if you call into our support team and work with them, we can work together with these companies to make sure your problem is solved wholly versus kind of just shifting you off to somebody to get a support. And then we work very closely with them on how SQL Server is running and performing on kind of a daily basis. And so those are the distributions we support. We also support, I said, Docker containers, and then of course still Windows Server and Windows 10. And if you just look at this picture here, you may ask yourself, why did you guys do this? Why did you build SQL Server to run on Linux? Is it the fact that now Windows is not an important platform for SQL Server? And that is not the case at all. In fact, at a recent conference, somebody asked me, hey Bob, should I run SQL Server on Linux, Docker, or Windows? And my answer was yes. And I wasn't trying to be funny or tongue-in-cheek, but that's really the truth. We really built SQL Server to run on Linux and Docker because we wanted to give you choice, and customers were asking us for choice. They were not happy with other database vendors that were running on, say, Linux or Docker, and they thought SQL Server was a great price performance engine to run for their platform. And so that's really the reason we did this. And so for us, we just want you to run SQL Server. We think Windows Server is still a great platform, but Linux is now a great and upcoming platform for you to run our product. The next question I get is that, okay, that's fine, Bob. You got SQL Server on Linux, you got SQL Server on Windows. Is it the same? Are the same features exist? And if you look at this table right here, the answer is for the most part, yes. If you see on the right-hand side where there's not a dot, these are some of the gaps maybe perhaps where SQL Server on Linux today with SQL 17 doesn't have that functionality. The core database engine on SQL Server is the same between these platforms. And this is why many of the dots you see actually line up to be exactly the same. And so a couple things you might see on here are machine learning services for R and Python don't exist yet, although we're working on it for SQL on Linux. But something like native scoring, which is core to the database engine, that does work across these platforms. And then you look at the top here, some of our BI services, such as analysis services, reporting services, those don't run yet on SQL Server on Linux. Those teams are certainly thinking in the future about whether they should support those. You could always actually put those on a Windows environment and connect them to SQL Server on Linux, but they don't exist to run natively. But SQL Server integration services, for example, it runs on Linux. SQL Server agent runs on Linux. And then all these core capabilities you see in the middle here all run both on Windows and SQL Server on Linux. So that's an interesting slide, but what is the Bob Ward perspective? This is kind of my perspective, and that is the core database engine is completely unchanged. And you're going to see in the architecture section when I mention it of why it is the same SQL Server engine that you know and love running on both platforms. The deployment experience is different. We're going to show you that today of why it's different. For a lot of people that run SQL Server setup on Windows, you're actually going to like the deployment experience on Linux probably a lot better than you see it on Windows today. We rely on something called the SQL PAL, which we're going to talk about in an architecture slide. And you do have authentication decisions and choices like you do on Windows. For example, we still support standard SQL authentication, but we also support Active Directory integration. And we have a slide talking about the steps you'll have to go through to make that happen. Failover clustering is fully supported, so is availability groups. But because Windows Server clustering doesn't exist on Linux, we've partnered with a package called Pacemaker, which is a free download, for you to support either a shared storage solution with failover clustering or availability groups with a non-shared storage solution. Some of the Windows config things that normally come up from MySQL audiences, things like lock pages and instant file initialization and large page models, some of that stuff doesn't even apply on Linux. And we've got some documentation and some stuff we can talk about why that's the case. Encrypting connections is fully supported on Linux. It requires some Linux specific things, and you're going to find that throughout the Linux experience that a lot of the functionality is going to mirror to a SQL on Windows experience. But because it is the Linux operating system, there's a few special steps or maybe a Linux package that has to be installed to give you that same functionality. Now, what's not on that table over there are a couple important features that customers do ask me about, and that is distributed transactions and SQL Server replication. Those technologies are not supported on SQL Server Linux today, but we're actively working to make sure those are supported at some point in the future, because we know that for SQL Server on Windows customers, those are popular features they need. Another question is about multi-instance. So we don't support running multiple instances of SQL Server in a Linux environment, but you're going to find out later in this presentation with Docker containers, you can achieve the same functionality, and that's our preferred method in a Linux environment. And then finally, if you're on the phone here today and you're a Windows user and you really haven't played with Linux, but you'd like to explore SQL Server on Linux, you're probably asking, do I have to know Linux? And the answer is, like anything else, maybe. My contention would be is that out of the gate, to get SQL Server up and running on Linux, it's very simple for you to be able to do, and you don't need a lot of Linux knowledge. And then if you have your applications that connect to SQL Server on Linux, they can run pretty much unchanged, so then you don't need to know that. But if you're going to go for a full-blown optimized SQL Server in production on Linux, you probably do. You probably do need to learn more about the operating system, but it'd be no different than you kind of understanding more about Windows and understanding how to run SQL in an optimized version as well. We've got a performance best practice advice for you to go through and understand what kind of things maybe you need to tweak and tune from either a SQL or a Linux kernel perspective to make it run at its most best optimized performance. You're going to find that the deployment experience, as I said, is different. And the reason is that the Linux operating system has a different deployment ecosystem, typically centered around something called a package. And depending on the distribution, you'll find programs built in to run and install programs like SQL Server from a package perspective. For example, on Red Hat, you have a program called Yum that you use to install SQL Server. We're going to see a demo of that. And the package concept gives you some advantages. For example, for us, we've split out a lot of the functionality into different packages you see in the bottom of your screen here to make installation very light and faster than, for example, in the Windows environment where almost everything comes together in one big installation file and you have to go through a series of steps to decide which thing you want to install. In Linux, we decided to break it up in terms of which package you want to get that choice. So the MS SQL-Server package is just the core database engine plus SQL Server agent. And other benefits using this ecosystem is that dependency management for things in Linux that we depend on are automatically pulled down depending on how you run the actual installation process. So we embrace the package ecosystem for all our major distributions and run natively with them very, very well. Now, in the Windows environment, you're used to something called SQL Server Configuration Manager to actually make changes and configure your SQL Server for things that are not possible through T-SQL, through like SP-configure or alter server configuration. Those T-SQL interfaces are the same on Linux because the same SQL Server core database engine is running on Linux. So how do you do that? How do you install SQL Server and then do some of that configuration choices? For example, how do you set up the TCP port for something other than the default, or the default data directory or log directory or backup directory? There is a bash script. Everything in Linux is scriptable. So there's a bash script called mssql-conf that relies on a series of Python scripts to help you through this process. So when you go through install SQL Server, as you're going to see in a second, we'll use this bash script to kind of configure SQL post setup. And then anything after the fact, you can use mssql-conf to do other configuration choices that the SQL Server process will inherit and pick up. Linux is an environment, an operating system, and a shell that embraces environment variables. And we have rich documentation about how to use and set environment variables to also help pre-configure SQL Server in an unattended fashion. And in fact, because we have a package management system that we embrace with Linux, doing an offline installation or an unattended installation is very natural and easy to do. And we have complete documentation on how to do that. And same thing for updates. Updating SQL Server for, say, a cumulative update is very simple to do through the normal package management system. And I should say, we've got documentation for you as well to decide, do I want my updates to cumulative updates, or do I want them for the general distribution train if I'm just looking for security and critical updates? And if you haven't heard yet on SQL 17, starting with that release, we no longer do service packs, and that also is the same in the Linux environment. So updating to the latest release is either the process of just installing if you have not installed yet, or using the update process to upgrade to a new cumulative update. You can roll back to a previous update, very simple, to a previous cumulative update release, and then uninstall is a very, very simple process. And in fact, we offer this option, if you do an uninstall, that you can keep your databases and system databases intact to do a refresh of the install, or you have instructions to remove the directories where you install SQL Server in a very easy way. The architecture probably deserves a little bit of mention here, because people ask us all the time, like, how'd you do this? How so quickly did you move to build SQL Server on Linux? It's a fairly complex diagram, and if any of you attended the past summit last year, I did this kind of exhausting 3-hour debugging deep dive on actually this architecture. But let me just describe this to you. So effectively, there was a project at Microsoft Research called Drawbridge, which was way back in 2011, kind of before containers became popular. And that concept is like a container. And the concept was, if you're an application running on Windows, is there a way to actually build a process around your application that is more lightweight than a normal Windows process, in the sense that only go down to the kernel of Windows when you really, really need it? And some of the functionality from Windows APIs would be implemented inside user mode to make things lighter and faster. We took that concept and borrowed it and made it things run on Linux. So if you look at this diagram here, on the left-hand side, this bracket of the red box and the black box describe the entire Linux process called SQL Server running on Linux. And in the red box itself is actually hosted here the SQL Server process that you know on Windows, unchanged. It's the same SQL binary that runs on Windows and SQL Agent. They run within this entire Linux process. And when they need to make calls to the Windows operating system via either SQL OS, which we've had for years in SQL Server, or through other Windows APIs, they are implemented across this platform extraction layer. So if SQL Server needs, for example, to make an API call to the registry, that remains unchanged running on Linux, even though there isn't a registry concept on Linux. But the SQL PAL will implement all of that functionality inside its own process without going to the Linux kernel. But for example, if SQL Server needs to use SQL OS to get a new thread to run in processing, we need to use kernel services in Linux to do that. So that's where we'll make this transition to something called the host extension, which is natively compiled for Linux to go to the Linux kernel to actually get a new thread. Now, this diagram is bigger and thicker than things look. Sensitive code paths to do things like I/O, memory, threads, they're very lightweight. And we make this transition to go from this SQL Server concept of what SQL Server thinks it's running on Windows into Linux through a concept called an ABI, an application binary interface. And it's just a clever set of assembly instructions for us to transition from what SQL Server thinks is a Windows ecosystem into Linux. And the thing that makes this all gel is the fact this is all Intel processors. I mean, my colleague Robert Dorr once told me, he said, Bob, you realize that the SQL Server code is assembly down to machine instructions for Intel, and that runs no matter what, whether you're running on a Linux or a Windows system, as long as it's Intel architecture, it runs the same. The difference is when you have to make calls into the Linux kernel, you have to do some transitions to make that happen, and that's what this host extension piece is all about. So this SQL platform abstraction layer called SQL PAL is the secret sauce that allows SQL Server to run unchanged in a Linux environment. You see down here in the right-hand corner here, the parent watchdog process. And the concept is that when you run SQL Server on Linux, there are actually two SQL Server processes. There'll be two executables called SQL, two process IDs. One of them will be this parent process, and one will be the actual Linux process that you see in the diagram on your left. And the reason we call this watchdog is that its parent process has the ability to detect through a concept with Linux core dumping to understand if a core dump has occurred for SQL Server and to be able to generate a core dump file for debugging purposes after the fact. But I pulled this in this diagram here because people sometimes will see SQL Server on Linux and see two SQL servers and think that we do have this multi-instance concept, when in fact, there's always a pair of them. One is the parent process that starts out as Linux code, and it forks off the new Linux SQL process, which is the true SQL Server engine. The last thing to comment in this diagram here is what is compiled for Linux. The only thing compiled for Linux is the host extension black box and the shell of this parent process. Everything you see in this red box here is all code that was compiled for Windows that are binaries that run unchanged in a Linux process. So hey, let's take a look at it. Let's actually see what this looks like. Many of you may not have deployed and seen the Linux experience. What I have in front of you here is a program I like to use on Windows. I'm running on a Windows 10 laptop called MOBA Xterm. It's a free download. It's a secured shell environment. If you're a Windows user, you're used to remote desktop, you're thinking, how do I remote desktop into my Linux environment? Well, you don't have that, although there may be programs out there that emulate that. You usually use something called a secured shell, and there's all sorts of ways to do it. And on Windows, I love this MOBA Xterm. This is a secured shell into a SQL Server on Linux in a virtual machine running Red Hat on Hyper-V on my laptop. So everything is contained here on my laptop. And what I'm going to do is I'm going to run what the simple installation experience looks like to install SQL Server on Linux. So I'm going to run sudo as a command to run things as super user, as root, which I need to do to install SQL Server. and I'm going to install SQL Server. I'm going to do -y. Excuse me, I need to do install here. Install -y. And I'm going to use -y to say, don't prompt me to actually do the download. I'm going to put in my root password for this Linux environment, and I'm going to let it kick off. Now, what is it doing right now? What it's doing is it's actually going to the internet, to our package repository, which is like an FTP server, to pull down the binary of the latest version of SQL 2017 on Linux to my actual Linux environment. So it'll just suck down what's called an RPM file for Red Hat, which is a binary package that we know how to build as a protocol for how to build one of those. It'll pull that down, and now it's going to go through the install process. The install process is going to actually create some directories, some known directory locations on your Linux environment, take that binary package and extract it out and put things in its right place, put the binaries in its location, and then go put into another location where the application files go, things like system databases and so forth, and create like an MS SQL user. We have think of like a SQL service SID in Windows. There's an MS SQL non-interactive login user for the SQL Server process. And within just less than almost like a minute of time here, it's going to finish. The last thing it does is it registers itself as what's called a system MD service. There is a service concept on Linux, and then that's finished. And then the last step is to run this bash script to finish the setup process. So I'm going to paste this in this window here. I'm going to run it, and I'm going to get some prompts. I'm going to say here I'm running Enterprise Core Edition. You'll notice here when I did that, it didn't ask me for a process ID. That's because if you're just running in a volume license environment with SQL Server through a contract, you don't even need to put in your process ID. We trust you here at Microsoft. I'm going to accept the EULA, and then I'm going to put in my SA password. And it needs to confirm it. And I'm going to let this finish. This is running a bash script that is going to actually launch the SQL Server process to configure this information. It configures my Enterprise Edition. It's going to ensure I accepted EULA and configure into master the SA password. And believe it or not, I'm done. That is the installation process of SQL Server on Linux. And the way I can verify that is I can use this command called systemctl to see if SQL is running. And sure enough, I can. Now notice right here, when it does this, it lists two processes. Do you see that right there? The first process is the parent watchdog process that I mentioned. And then the other process, 3329, is the actual SQL process. And that type of program, systemctl, allows me to see the status of a service, to stop the service, restart, however I want to do with SQL Server. One of the things out of the gate you may want to do is take a look at the error log. Well, where is that located? Well, it's actually located in a directory called var opt MSSQL. So I'm going to actually dump out the var opt MSSQL log. In the log directory, you're going to find is where the error log and the normal log files are, like the system health session, dump files, things like that. So by running that command, I've dumped out the SQL error log, and as you can see, that pretty much looks like the standard SQL error log you know and love. Another thing I might want to quickly do, now I've already installed the tools. The tools are separate. SQL command, BCP, et cetera, are separate. And I've already done that in this particular case. But one thing I might want to do is actually just restore a database, like the wide world importer sample. So I don't want to keep using SA, so I've written a series of shell scripts here, which you can get access to up in my GitHub repo. And one of them is to add a new login for SQL Server called SQL Linux, and I'll put in my SA password here to do that. Now I've added my login. Now what I'd like to do is like to restore this database. Now for Linux, you have a way of creating several different directories for your backups, but the easiest thing to do is to copy your backup into the var opt MSSQL directory, which has full permissions for the SQL engine to access that file. So that's what I'm going to do here with this shell script. That's just going to copy over wide world importers into my var opt directory, and then I'm going to restore it. And you can see here the restore script is simply going to run SQL command with a SQL script to restore SQL Server on Linux. So let's just go do that. Restore wbi.sh. Now what this is going to do, again, is running SQL command to restore SQL Server on Linux. This is just like on Windows. Now, this wide world import is the SQL 16 backup. So one of the things it has to do, of course, when it does this restore, is run the upgrade steps. But because of the fact the core database engine is the same between Windows and Linux, I'm able to take a SQL Server backup on Windows, copy it to my Linux environment, and just do a restore. Because that's exactly what I did right here. And now I'm up and running. And I can even do something funner than this. I can run one of our new tools, our cross-platform command line tool called MS SQL CLI. I'll connect a SQL Linux in this case. I'll put in the password. This is a Python-based command line interface that has IntelliSense. You can see here I'm running with IntelliSense capabilities. I can see what version I'm on. I'm running Enterprise Edition core licensing on Red Hat. Or I can even just go into wide world importers here. So using IntelliSense, I'll go into that database, and maybe I'll do a select star from the sales, a table in the sales schema. So I pick like maybe these special deals table. I run that, and I get my results back. So there I have it. I've installed SQL Server on Linux in probably about a minute. I restored it to backup in another minute or so, and I'm up and running now. And I'm telling you, that's as simple as it gets. And that is the process to install SQL Server on Linux and do some basic deployment techniques. And then you'll just go from there. But remember, it's the core database engine. So you want to do column store? No problem. The interface is the same. You want to do in-memory LTP? The interface is the same. When you start getting down to availability groups and some of those things, you have some differences for configuration, but the functionality is the same. Okay, Tom, let me stop for a second and see if there's any questions we have from folks attending the call.
Bob, we have a few questions here.
Yeah, let's go. Let's do it.
Might need to take them offline, but we'll see.
Okay.
He's saying, in Docker, where can I configure a proxy server for use behind a company firewall?
Yeah, we'll have to pull that one more offline, but there are processes for you to do that. There is a way to configure your Docker. The Docker pull that you would do probably doesn't have that configured, but through Docker file, you can configure in the container itself to open up the ports for SQL for firewalls. That's all possible. Okay.
And then the application you were using, the I'm going to call it an RDP session, but
MOBA Xterm. MOBA Xterm. Yes.
Yeah. Can you actually spell that for
Sure. MOBAXTERM, MOBA Xterm. You can just look that up on the internet. But by the way, there are other secured shells that are very popular. So if you're a Mac user, it has a built-in secured shell in the command line area. Windows 10 has a new bash shell that you can install natively on Windows 10. It comes with a command line secured shell. I love MOBA Xterm because of a couple of reasons. If you look at that interface, I'll go back here and pull that up. It has basic drag and drop capabilities to copy in files from your Windows environment, and then it supports copy paste. So I can copy something from my Windows, notepad file or whatever, and paste it into the shell. And it's got ability to do other things besides a secured shell. So I like it. It's a free program you can install. There's also a paid version you can actually go through and with more functionality. So if you look on here, it's MOBA Xterm.
Okay. And do you know whether it runs on Windows 7 or not?
The question is that does MOBA Xterm run on Windows 7? And the answer is I don't know the answer to that question. You can look at the MOBA term site. I bet it does. I've only been using it on Windows 10.
All right. And let's see. And I'm kind of looking at some of them are saying, are there plans to remove the OS Active Directory config, allowing you to only have to configure SQL Server with AD rather than registering the host?
So I'm not sure exactly what you mean by that question. We're trying to improve the Active Directory experience to install SQL Server on Linux with Active Directory. So I'm not sure exactly what the question is. We're trying to improve that experience. Today, I've got a specific slide where I just kind of briefly mention it. The idea is that you must register the SQL Linux in the Active Directory domain. And I'm not sure exactly what other step you're referring to that we're missing. So contact me at bob.microsoft.com on that specific question, and I'll go through it with you.
Okay, and for SSIS on Linux, is that right that we have to create our SSIS packages in Windows, which means an extra license for it?
So the question is that do I have to create my packages as SSIS on Windows? Send me a question on that one. I honestly haven't delved into that. I know that you can run all your packages on Linux. I'm suspecting that if you know and how to build a package, you can actually build that package in a Linux environment with the right formats. But more advanced package creation capabilities may require running on Windows, but send me a note on that one. If I can't answer it, I'll put you in touch with the SSIS team to get an answer for you.
All right. And then the next one, in a Linux Docker container, is there a suggested supported method for accessing large databases with persistent storage from a desktop? Example, developers installing a container with SQL and writing code against a large shared prod databases over 100 gigs in size.
Yeah, I mean, so Docker containers support persistent storage. So I'm not sure if you're referring to the fact that can you do it, or is there a way to do it? But Docker containers have the ability, when you run the container, to specify a shared volume that multiple containers might access. In that particular case, though, you know, when your container is running, while Docker may not prevent you from doing this, that may not be a great idea to have multiple people hitting it as developers, right? Because if Docker doesn't prevent multiple people hitting that, then maybe you're going to trip over each other. Docker's really, it does support persistent storage. And the main reason to do that, of course, is because if you remove your Docker container, you're going to lose whatever thing you've done in the container itself. So let's drill into that a little bit more in the Docker section. I've got some slides on that.
All right. I'll let you proceed in your demonstration.
Okay, thanks, Tom. And again, I want to emphasize, if there's a specific question that I wasn't able to address here on the session today, email me at bob.ward@microsoft.com. Plus, Tom said that if we can't get to everything, we will compile these answers offline, and he can post this on our website, on the virtualization chapter website. Okay, so if you think about the bread and butter of SQL Server, it's about performance, security, and high availability. So we wanted to make sure, from a SQL Server perspective on Linux, we support all of that, right? And it runs very well. So from performance perspective, we want to leave any doubt for anybody that SQL can perform on Linux, even with the architecture I described to you. So the very first benchmark that was released for TPC-H was on Linux for SQL 17. And then since that time, the #1 TPC-H benchmark for 1 terabytes has also been released, for the first time achieving over 1 million query per hour type performance. And then the price performance is really, really low. And it was achieved by this concept called a diskless database with HP Enterprise. Column store indexes, in-memory TP, scanning rows in a very, very fast way, adaptive query processing and automatic tuning. The SQL Server core engine is unchanged. Slava Oaks, the inventor of SQL and Linux, told me one time, he said, Bob, the query processor is a query processor. That code is not any different. So when you think about these type of features and functionalities, you know, and you think about, well, do I have to pick Linux or Windows to get that? The answer is, it doesn't matter. Because our core engine for SQL binary is the same running on both platforms, you get all that functionality. But you may be interested in how to tune Linux and SQL Server to its maximum. And so we've got some best practice guidance that when you look at a slide deck and click on there, you can see in our documentation. Here are the tuning parameters for SQL Server on Linux that you may want to take a look at. It's not a large list, and we continue to evolve that. In fact, I need to refresh that because we got a few little things that we want to add to it. But I will tell you, I've had customers that don't even go through that guidance, run SQL Server on Linux, and they get the performance they need for their workload. So don't think that you're going to have to go through an exhausting exercise of tuning Linux to make it run for your workload. But it doesn't mean that you don't want to go through this and take a look, because there could be some advice that you want to see. And sometimes hearing from our customers matter, right? Like, what do they think? This company, DV01, was a Postgres customer that was running out of scalability for using Postgres in their Linux environment. They moved to SQL Server on Linux because they're a Linux shop, and they got great scalability results, especially be able to apply technologies like column store without a lot of app changes to make it work in their environment. Security, same way. So transparent data encryption, TLS encryption in transit, always encrypted, row-level security, dynamic data masking, auditing. All those features work on SQL Server on Linux. Now, for things like TLS, there's going to be some things that we have to do special to make it work in Linux, like we use OpenSSL, and there's some Linux configuration steps you have to go through to make that work. But again, the thinking is that security is really, really critical to you, so we want to make sure those security features run, from your perspective, unchanged, even though there might be some configuration things you have to do to make it work. And then you mentioned, somebody asked about AD authentication. I'm interested to know your specific question, but the setup and config have to be a little different. For example, we need this rel program, this package, to be able to join a domain from a Linux server into the AD domain. And then we use Kerberos, and we use programs open source like GSS API to actually make all this work behind the scenes. So the steps are this. You join your SQL host to an AD domain, and then the Active Directory, you need to create a user for SQL Server itself and set your service principal network to make sure that works. And then you configure inside SQL Server on Linux in a key tab for the service itself to be part of this domain. And then you do things that are very natural SQL. You're going to go into Transact SQL and create your AD-based logins, and then you start connecting and specifying, I want to use AD Authentication. And those are the steps to actually make it work. And our documentation is a complete set of steps like this to go through in detail how to make this happen. Love to hear your feedback if you've already done this or you're struggling to make this work. Let me know. I'd like to hear whether you think we need things to make this experience better. We're already working on that, but I'd like to know for those of you that are looking at this, what do we need to do to make this world-class? So HADR deserves a few minutes to talk about for sure to make sure we cover it. So first of all, these are kind of the options now in SQL 17 to do high availability. One is failover cluster instance, and you're familiar with that in the Windows environment. You would set up Windows server failover clustering and a shared storage scenario. And we support that with packages like Pacemaker and CoroSync in Linux and a single SQL Server instance with our resource agent package. You can use these shared storage options to prop up a failover cluster instance between two SQL servers on Linux, and that works just fine. If you want to use availability groups and you want high availability, in other words, you want auto failover, you would still use packages like Pacemaker and our resource agent. And when you go in to specify your availability group, you're going to pick a cluster type equals external. And that is what's required to do availability groups for high availability. But there's one other step. Because of the fact that there are certain things from a metadata perspective that Windows clustering provides us that are not on Linux, we require a third replica for high availability. In other words, we require a third SQL server. We call that a configuration only replica for metadata purposes. And the good news is that can be SQL Express. So it can be a completely free version of SQL Server to help you make that happen. And you get full AG capabilities for failover and availability groups when you do that. New to SQL 17, though, on Windows and on Linux is this concept called cluster type equals none. No clustering software required. But notice it's not called highly available because no auto failover capabilities exist in that scenario unless you build it in yourself. You can do failover, you can do sync, but you're the ones required to decide when a failover happens. This can be very powerful, though, for a scenario for two situations. One is read scale scenarios. So you may have a Linux server where you'd like to prop up a multiple set of read-only replicas and then route in a round-robin fashion and a load balance scalable fashion a bunch of readers to your replicas. But you don't want to do clustering. You just want to do it for that purpose, and then you can decide whether you want to take one of those replicas, make them sync, and do your own failover logic. So again, failover cluster instances supported, high availability groups are supported, and also this new concept called a read scale availability group that does not require clustering. Now, in addition, one other possible scenario is cross-platform. So you have the ability now to take SQL Server on, say, Windows or Linux, make it a primary replica, and make the other platform be your secondary replica, and it works just fine with availability groups. That would be a clusterless scenario. And because of the fact it's the same core database engine running on Windows and Linux, we're able to achieve this. This is possible for a possible live migration scenario. You're running SQL Server on Windows today, and you're thinking about moving to SQL Server on Linux, but you want to know, how can I do it in a live migration fashion? You don't have transaction replication, so this is one way to possibly achieve that, actually. You would set up your SQL Server on Windows as your primary, SQL Server on Linux as your secondary, and then you would start replicating across in this clusterless way, and then find some sort of breakpoint or breaking stop to actually change over to now point everybody to your new SQL Server on Linux replica. There is a demo that I have available. We don't have time to run through that today. That's on the GitHub repro to show how this cross-platform works. And then today, the way that works is it uses certificates between the two environments, kind of like you did in mirroring, but it shows you all the steps you have to do to make this happen between these two worlds. It works. I've done it many times, and I've actually demoed it. I encourage you to give that a shot and try it so you can see how easy it is to set that up. Okay, let's kind of take the last part of our discussion, our last 20 minutes, and talk about Docker containers. If you've not spent any time looking at Docker containers, I need you to think about it this way. Think about a decade ago or so, when people were looking at virtualization and saying, I don't know about virtualization, SQL Server is not really ready to run in that environment. I don't think that's applicable to run SQL Server. Now, of course, SQL Server in a virtualized world is a very popular way of deploying SQL. And I think the same thing you should think of Docker containers, in my personal opinion. I think Docker containers are new to a lot of people in this environment for SQL and databases, but could become very, very popular down the road for many different types of scenarios. This isn't virtualization. It's a lot more lightweight. It behind the scenes, the Docker container engine takes operating system resources and share those across the containers, which is another reason why it's so lightweight. Plus, in many cases, when you take this idea of a Docker image, you only need to put things in there that are required to run your application from the operating system perspective. In the actual image, though, is the image of the operating system necessary binaries and your application, which in this case could be SQL Server. And then a container is kind of a runtime instance of that image you built. So you pull down your image, and then you go run the image as a container now. And in the case of SQL Server, you can do multiple of those, and we'll talk about how do you achieve that. Think about these three possible scenarios I've listed at the bottom here. My colleague Travis Wright, I was talking about Windows containers a little bit, and what is it going to take for us to eventually support those for a full production like we do Linux containers? And his answer back was, why do I care? And so I said, hey, what do you mean, why do I care? And he wasn't trying to be trite. His comment to me was, imagine a world of database containers. Imagine a world finally where you could prop up these containers with SQL Server, and as a SQL professional, you don't care what operating system is running in the container. That's a pretty powerful statement, and we may not be there yet for that, but that's a kind of future I think the containers give promise to. I think earlier there was a question about shared and persisted databases for developers, but if you've not seen this idea of DevOps or continuous integration, continuous deployment, containers give that capability at some point, and some customers I've seen adopted this where they don't create a shared persisted database for SQL Server. They build out through Jenkins pipelines a SQL Server database with test type data for a developer, and then each developer gets their own container with SQL Server, with the test database, with a subset of production data, and they run against that environment. And then, so SQL Server embraces that through containers to build those kind of type pipelines. And then finally, if you think about HA scenarios and you think your only options are availability groups and failover cluster through what I just described, there are new ways to do things. Kubernetes is an orchestration. It's not new, it's been around. It's an orchestration piece of software that understands how to orchestrate and support high availability for containers. And we fully embrace that. We've got documentation and tutorials to show you how to run Kubernetes in Azure Container Service with SQL Server in a shared storage way to achieve high availability across your containers. I've got a slide to talk about that. So how do you do this? Similar to the SQL Server Linux deployment scenario I just described, you can in a matter of minutes get up pretty fast on Docker. So notice this command Docker pull, and this is an example of in a Linux shell you'd be running. I'm going to show you a demo in a second running on Windows, Docker engine on Windows. You do a Docker pull for our latest SQL Server Docker image, and then you do this Docker run. You actually do a run of this image specifying your EULA, your SA password. We'll talk about the port in a second. Maybe you're going to name your actual container, and then you actually point to what is going to be the distribution I'm using, or what's the Docker image for SQL Server. And if you've got an image pulled down, I'm using that specific image. You could run several different images of SQL Server. It may not be the latest. It may be a GDR distribution. And boom, Docker Eng will kick this up, and now all of a sudden you're running a full-blown container with Linux running inside this guest using SQL Server. And if you need to connect to it, how would you do it? Well, first of all, Docker supports this ability to inject a process into the container and run it remotely. So you could do this Docker exec to run a bash shell, and all of a sudden you get an interactive bash shell to work with your container, or you can connect outside the container with any tools that support SQL connectivity, like in this case, SQL command. And then you just fire away and start running SQL Server like any other container. So before I go on, I just want to make sure for folks on the phone that are Mac users, I'll just throw a challenge at you. Actually, I did this at SQL Bits. I had a person in the audience at SQL Bits say, I'm a Mac user. I don't want to run SQL Server with virtualization things on my Mac. How do I do this? And I'm like, hey, I'll tell you what. Go pull down Docker Engine for Mac. Go do a Docker pull of our SQL Server image. Install SQL Ops Studio, which is a cross-platform open source tool that runs natively on Mac, and you're going to be up and running with no virtualization requirements at all from SQL. And this person did it and got on Twitter and said, he's right, I did it. I did it in a matter of minutes and it worked. So for Mac users out there, there's an answer to run SQL Server now in your environment with no virtualization requirements, and to have tools that are native to your Mac experience. So how do you do it in production though? Because the Docker image that we have on the Docker store is a developer edition, which is a free version of SQL Server. So in the Docker Hub. So there's something called the Docker store where you register for. And in the Docker store, when you set this up, you can then now run your Docker image and put in the enterprise, the edition of SQL Server, like enterprise. So then SQL will then recognize you're running a full-blown paid version of SQL Server, and now you're running your Docker container in production. The Docker Hub today has Docker images for Ubuntu, but we have instructions to how to do something called Docker Compose and a Docker file to build a Docker image for, say, Red Hat or for SUSE. And we're looking to embrace in the future other container environments like Red Hat's container catalog. SUSE's got a catalog as well. So we're looking at other ways besides just the Docker Hub's place to pull down and run images. And then I mentioned about running multiple containers. Notice this syntax here that's yellow here. To avoid port conflicts, you can specify with this parameter to map this port number to that port number. So now you can run two containers. They'll both be listening on these different ports. And then when you connect to SQL Server, you would then connect to that port to get to the specific container you wanted to connect to. And then Docker also allows you to pull a specific version of Docker. And so the hub includes the engine and the tools. The licensing is the same model. And in fact, I should say and stop right now to tell you that SQL Server licensing for Linux, if you have a contract with Microsoft or you buy a SQL Server license independently, that license works for both Windows and Linux. You don't have to buy separate SQL Server licenses for Linux and for Windows, and those licenses apply actually for your use of Docker. Supports availability groups. There are Docker files for implementing Docker on CentOS and RHEL, and then we have a separate image if you want for the MS Tools Docker image itself. And then the question was asked about data persistence. When you actually run a container and you stop and start that container, any persistence that you had, like creating a database, would be kept there. But if you remove the container, you will lose any data you stored, like a database. So Docker does support this -v parameter, the way for you to say, here's my actual persisted volume that will remain unchanged, even if the container is removed, and you can map that to a directory like var opt MS SQL, where the SQL Server databases will be stored. So you have the ability, and you notice here, we talked about that the host data location is locked by the Docker process actually. So multiple containers can't access that same drive. So if you had a SQL Server database that's persisted and multiple containers going after it, only one would be able to access that at a given point in time. So I mentioned about Kubernetes. Consider this type of scenario with Kubernetes. So we have this concept called nodes and pods. So you would actually deploy your MS SQL Server container in Kubernetes, and it would actually put it in what's known as a pod. And then it's accessing this persistent volume, which is shared storage. So what happens is if the container fails, like a SQL Server problem or a Docker container problem, Kubernetes will automatically start a new container in a new pod on the same node within the Kubernetes cluster. But if the actual node itself has a problem, if the node hosting this has a problem and has an issue, and the SQL Server container would now fail, Kubernetes will start up a brand new container in a new pod on a new node, all automatically once you register yourself in the Kubernetes cluster. So it's the same shared storage of the database. So the database is the same. It's just SQL restarting to access that database, pretty similar to like a failover clustering environment, except there's not a SQL Server waiting around. Kubernetes supports the ability to instantiate a new SQL Server within the new pod or within the new pod on a new node. And then the app will use the same IP address, kind of like the listener concept throughout this process. So take a look at our documentation on how to do this. We fully embrace Kubernetes. You're going to see new scenarios we're going to light up using this type environment. If you haven't seen our tool story, you're used to Management Studio, and we still embrace, and Management Studio, because it's the same SQL Server core engine, will run against SQL Server on Linux. But there's some new tools we're actually developing. For example, the Visual Studio Code MS SQL extension embraces Visual Studio Code, which, as you may know, is cross-platform and open source. We have a new tool called SQL Operations Studio, cross-platform and open source, and I showed you a brief demo of MS SQL CLI, which is brand new in preview. That's cross-platform and open source as well. And you're going to see the direction for Microsoft is to do exactly that. We, in new tools we're going to build, are going to embrace open source and cross-platform from a tooling perspective. We fully still support Management Studio as an environment, but you're only going to see that because of its dependencies in Visual Studio supported in a Windows environment. And then Commandline Tools, which is very well embraced in the Linux world, we're a very, very big believer in. And so we have these command line tools for SQL command, BCP, scripter, and even DBFS, which allows you to look at DMV data as a directory. Those work on Linux, and in these cases, these work on Linux, Mac, and Windows. And then MS SQL CLI, I guess the new one, which is supported on Mac, Windows, and Linux. That's a command line version that has things like IntelliSense built in, which is a little bit different and more robust than, say, SQL command. So again, from the tools perspective, embracing open source, embracing cross-platform, that's certainly a direction for us. Let's take a look real quick at Docker if you've not seen this before. This is running Windows, so I've installed the Docker engine for Windows. And if I run a command like Docker PS, that says what Docker containers are running on my process. Now I've got some command line files that are on my GitHub repro for you to take a look at. And if you look at this one, docker run.cmd, you can see that I'm going to run Docker by accepting a EULA. I'm providing environment variables for Docker to use to install SQL Server. I'm mapping port 1401 as 1433, so that's the port I'm going to connect to. And I just name it SQL 1. And I'm saying, use the latest Docker image that I pulled down. So if I run this, it's going to look something like this. Docker is going to kick in. It's spinning up a new image, a container image of SQL Server on Docker, and I'm up and running. And so if I run in something like Docker PS now, this is my Docker image that's up and running. So I could do all sorts of interesting things, but what I'm going to show you is using SQL Operations Studio. This is SQL Operations Studio running on Windows, and by using the local IP address, because I'm on my local laptop, I can actually connect and look at databases on this server. I haven't restored anything yet. I can go over here and click a new query, and I can run something like select add version, and I can run it. And this is now showing you here, let's get rid of this there, that inside the SQL Server I'm connecting to is SQL Server, the latest CU4 build, running Developer Edition, running on Ubuntu. Actually, let me scroll that out there so you can see it. This is running on Ubuntu. So what I'm doing is I'm connecting remotely into the actual container itself. Now, if you also haven't seen Operations Studio, it has this nifty little thing called Integrated Terminal. So if you go to the View menu and pick Integrated Terminal here, at the bottom window here, I have now a terminal access into my Windows laptop. And effectively, it's kind of like running PowerShell, although in this particular case, look what I'm doing. I'm running the Bash shell. So I could do something like this. I could actually do this. I could do Docker PS, so I can actually run my Docker commands if I wanted to from this terminal, or I could run MS SQL CLI. So MS SQL CLI -H is the name of the server actually. So let me put in my IP address, port 1401. And on this particular case, I'll just keep, I haven't added any login, so I'll just keep SA. And it's going to prompt me for the actual password here, for the SA password. And I can do the same thing. I can run add version, right? I can run SQL add version, and I got the same thing. So I love this integrated terminal concept because now effectively with Operations Studio, I could actually run SQL queries if I want to against my Docker container, or this could be any remote SQL server or Docker container in my network, and I can run terminal commands inside the same tool. So if I need to run certain Bash programs in here or Docker commands, I can actually do that. I love this kind of functionality because it allows me to have like one-stop shop for me to go after and do things from either a command line shell perspective or either from a tool perspective. So that's just a simple example. At this point, if I want to interact with this container, I could restore a database into it. I could interact with like any other SQL server. And of course, if I remove the container, I would lose my database. But if I started and stop, I can do something like this very easy. I can say Docker stop SQL 1. This is actually going to stop the entire container itself. Within the Docker engine's actually controlling all that. And then if I want to restart it, I can just say Docker start when it's actually done. So I have the same concept to say Docker start SQL 1, and now the Docker image, the Docker container's up and running again. I can connect and interact with it. So that's Docker container, really brief demo, all sorts of possibilities you go forward after the fact. So I want to encourage you, if you're a Windows customer today and you're thinking about the fact that I'd like to run a mixed shop. Again, Bob said SQL runs great on Linux and runs great on Windows. You know, what should I do? My company standard actually says that I should start embracing Linux more, but I need SQL Server on Windows as well. Well, take heart. I mean, here's a company, Convergent, that needed that concept. They had white boxes running SQL Server on Linux in their environment. They needed to, and they felt it was going to cut costs from them from a licensing perspective and get a better return on investment for their SQL servers than running everything just on Windows. Windows was great for them for some of their workloads, but some of their like tier 2 workloads, they wanted to do this somewhere else. Do you know how they did this? They did backup restore. They didn't need a live migration, so they literally propped up SQL Server on Red Hat Linux, running in their environment, their ecosystem, backed up the SQL Server on Windows database, restored to Linux, took the application and pointed with no changes to the Linux environment with a new server name, and everything worked as is. Their performance was the same. They didn't have any issues there. So it is possible to do something like this and make this migration if that's what you're looking for. Or you could be a customer on the phone that's running Postgres or Oracle on Linux and saying, now I've got this opportunity. How do I do this? We have migration tools to help you make that happen. And now you have this new opportunity and a new way of either getting scalability over Postgres or MariaDB or cutting your cost if you're an Oracle customer. Some people have already asked me, hey, SQL 17 got released last fall. That's really great, but you guys are pretty innovative. You just released one on top of the other within a year. Are you doing another one? And the answer is yes. As soon as we released SQL 16, we were already working on 17. And as soon as 17 was out the door, even before that was out the door, we were already working on SQL Server vNext. We don't have any dates yet to tell you. We don't have names yet even picked out. But I wanted to give you a feel for the themes we're thinking of. So it's no commitment to a set of features we're doing. It's more of what do we do? What do we think we need to do next? And the one thing that we think we need to do is take a look at integrating with big data. We introduced a feature in SQL 16 called Polybase, and we're kind of committed to looking at that as a functionality and a feature to decide, do our customers need better integration with their Hadoop ecosystems in a way that's very scalable, in a way that's very, very easy to use, using that common T-SQL interface you know and love. So we're taking a look at that. We want to embrace new container scenarios. For example, we want to do availability groups on Kubernetes. Today it's a shared storage option for HA. How do you do availability groups? What are some of the other container limitations that we have? And what are some of the new container platforms? As I mentioned about Redshift and SUSE, they have container catalogs. How do we embrace those things as well? We want to make sure that we have machine learning services on Linux and in containers. So we're working on that support for R and Python. But what other types of language scripting functionalities should we consider? Should we take a look at JavaScript? Should we look at Julia? Other types of things that data scientists like are those things that we should think about. We'll always continue to iterate on performance. Every release we do, we always push ourselves to say, how do we get faster? But we want to take things like adaptive query processing that we built in SQL Server 17 and build on that. How do we do things outside of batch mode for adaptive query processing, for example? Again, not a commitment to features, but things that we're going to certainly take a look at. We want to provide additional support for GDPR. If you're on the phone today and you're worried about GDPR, take a look at our guidance we already have out there. We have tools available to you that support SQL Server on Azure Database, SQL Server 17 on Windows, SQL 2008 on Windows, and even SQL Server on Linux. Tools to help you with vulnerability assessments and classification of your data. Those exist right now, but we want to keep building on that and give people additional tools. And then finally, for SQL Server on Linux, what are the feature gaps that we have that we need to shore up? So if you look at transactional replication, local login support, even bash scripting jobs for SQL Agent, DTC, things that you don't have today, what are those pile of features that we have to do to make sure that for you who are a SQL Server customer believe that we're almost 100% compatible feature-wise between the products. I have resources for you after the fact to take a look at. Remember, the deck is on this site here, and the demos are on my GitHub repo. Tom, I think I did it. I think I crushed this in an hour. That was fast, man.
You got it. You got it. So you did
was that the
very well.
mind-blowing pace that you were hoping for?
Yeah, that's your normal pace that blows the mind, but you did very well.
You need to go back and watch the recording a couple of times now, right?
Yeah, exactly. That's the good thing. It is recorded for everyone, so I will get it up on YouTube. It'll probably be Sunday, just FYI, because I'll be in SQL Saturday, Chicago this weekend.
Awesome. Hey, Tom, any last 2 or 3 questions that stand out for you that we probably should address before we end the recording?
Yeah, one of them said, can you use SCOM to monitor Linux and Docker?
I did get double check that. Please email me, but I'm pretty sure we've built a management pack out there that allows you to monitor SQL Server Linux with SCOM. Pretty sure that's the case. Send me a note and I'll double check to make sure that's, and I'll tweet that out if we've got that out there. I'm pretty sure we got that.
All right, and then one other one that'd probably be quick would be, does Docker start and stop affect SQL Server running? Does it mess anything up?
Great question. So when you stop a container, think of that effectively like stopping a virtual machine. So yes, if you're connected to that container, you would need to retry to that. So stopping container is like shutting SQL down and shutting the guest OS within the container down, okay? The beauty of it is that you can start it very quickly. So it's much faster than starting and stopping a virtual machine. Removing a container is completely blowing away the persistence on disk of what that looked like. So if you built a database in a container, starting and stopping will keep your database, but shut down and stop SQL Server. Removing a container completely removes on disk the database that you had, unless you use this option for a persisted storage.
All right. Well, Bob, again, I want to thank you for coming by. It's always a pleasure hearing you speak, even though you blow my mind a lot of times.
Well, Tom, I really appreciate it. I know I have more topics on this that are to come. This is a great chapter that I love you guys do, and I love speaking to some of the virtual chapters that pass. If you are on the phone and you don't know about these virtual chapters, there's a bunch of them, and they're great mechanisms for you to learn without having to do a lot of travel, right? So, Tom, I look forward to coming back and talking more about Linux and Dockers in the future.
All right, and I'll send you the questions that we have left over so you can answer them and get them back, and then I'll get them up to the users and stuff. So appreciate it.
Thanks again for everybody. Thanks, Tom, for having me today.
All right, and have a great day, everyone. Thank you.